Pretty epic question here. So Nigel writes the digits 1, 2, 3, 4, 5, 6, 7, 8, 9 into the grid and along each row. So we could just start with 1, but as the question indicates, maybe he starts with 7. And then when we get to 9, start from return to 1 again. Okay, and so we're interested in the total number of grids that we can make that are considered gorgeous, such that the numbers read along the rows, along the columns, and the two diagonals are divisible by 9. Well, straight away, that means that the digit sum has to be a multiple of 9. And if it is, then we'll be absolutely fine. The number will also be divisible by 9. So we just first of all look at the rows, because the rows contain the same numbers every time, and we're going to be adding up the numbers from 1 to 9. You can do this by hand, or you can use the formula half n plus 1. That's the nth term of the triangle numbers, so we get half of 90, or 45, which is divisible by 9 because it's 9 times 5. So every single row, no matter what starting number is going to be divisible by 9. I just want to make one other comment. I should have made this earlier. The 9 to the 9 comes from the fact that we have 9 options for the first number, and then 9 options for this number here, and then so on. And every single time we just times them together because that's the product rule of counting. So there are going to be 9 to the power of 9 grids overall. Now, let's write a few more numbers in and investigate the first column, for example. So maybe I start with 5 here, 2 here, 6, 1, another 1, 3, and a 4. And then obviously I'd carry it on 6, 7, 8, 9, 1, 2, 3, 4, and so on. Okay, let's look at the column sum. I'm going to get 8 plus 5, 13, 15, 21, 22, 23, 26, and 30. So this isn't going to be divisible by 9. If I focus on the first 8 numbers, then actually this would take me up to 26. So I can see for whatever numbers I put into that column on the left, there's actually just going to be one number that's going to work. If I replace the 4 by um, a 1, then it would be okay. So basically consider column 1, first 8 numbers will sum, so some multiple of 9 plus a remainder. E.g., it was 20, what was it? It was actually 9 times 2 plus 8 in the example on the left. If the 9th number equals 9 minus the remainder, then the column will be divisible by 9. If not, then it won't. What we therefore see is that 1/9 of the columns will be divisible by 9. So let's just go back over what we've talked about. We've got the fact that every row will add to 45 and hence be divisible by 9. If we take a look at the columns, the first 8 numbers, then we're going to get some number that's a multiple of 9 plus a remainder. The remainder could be 0. And then the ninth number, if that is 9 minus the remainder, so if it was 0, we'd add a 9. If the remainder was 1, we put an 8 there. Then the column would be divisible by 9. But if it's not that particular number, then it won't be divisible by 9. And so because there's 9 digits that it could be, and only one of them is going to make the digit sum be divisible by 9, then it's 1/9 of the columns. We then take a look at the next column. So for column 2, let's call this sum S. So if the ninth number, then actually we need to be a bit careful with column 2 because we're not always necessarily, actually I'm just going to write out a few more. So it worked when we had a 1. So let's imagine I'm putting the 1 in. Okay, because we don't always add 1 actually. See, sometimes we minus 8 because we start back to 1. Okay, I do these just an example because if we take a look at this column, then we can see that actually every number's just increased by 1. So I did have 27. This is now going to add to 36 because everything's just gone up by 1. And this one would be 45. And this one would be 54. And I can count that quickly because, as I said, every number's going up by 1. There's 9 numbers, so the whole sum will go up by 9. Now, something slightly different happens here because suddenly I'm not, most of the numbers are still going up by 1, but one of them is going down by 8. So actually, this is equivalent to doing 54 plus my normal um, 9. But actually, that one, if that one had increased to 10, then that would happen. But it's actually not. So I'm actually adding 9 and then kind of minusing 9. But what I'm trying to say is the sum actually in this case would stay the same, but it would still be divisible by 9. So it's going to still be 54. And we need to make an argument to show that actually if the first column is divisible by 9, then all the rest will be as well. Now let's consider the next grid. So, sorry, not the next grid, the next column. We'd get 3, 7, 2, 2, 4 here. And let's imagine we're going with the one that actually worked. We'd have a 2 here, and every number is increased by 1. There's 9 numbers, so the sum would have increased by 1 to 36. It was 27 when we used the 1. So that will still work if the first column worked. And proceeding in a similar way, sorry, not 8, 4, 8, 3, we can see we're adding 1 again here. So we get to 45. Similar here, 54. But take a look at the next one. This goes up um, by 1, but the 9 suddenly becomes 1. So actually, the sum isn't going to go up anymore. This time, every number goes up by 1, so we're actually adding 8, but then actually we're minusing 8, or equivalently, every number is going up by 1, but then that number which was 9 is then going down by 1. So we get the same thing. So there's going to be no difference. But actually, the key thing is that the sum still works. It doesn't matter that we've gone back to 1. Actually, if it was working, it's still going to work. And to put this in words, every time um, 9 goes to 1 in the grid, in a row, this is equivalent to 9 going to 10, since we are only interested in the divisibility by 9. And what I'm doing here is 9 is going to 1, but then I'm adding 9. That's actually what's happening. So essentially, we can just consider the grid as consecutive numbers from the start. Let's say our first number is x1, then we'd have x1 plus 1, x1 plus 2. It doesn't matter now that 9 is going to go to 1. I can ignore it, which means my final one will be x1 plus 8. Same with x2, x2 plus 8, all down to x9. Okay, so if column 1 doesn't add to a multiple of 9, then the grid is not gorgeous. It actually doesn't really matter what happens with the rest of them, although the rest of them will also not add to a multiple of 9, but it kind of doesn't matter. But if it does, then column n, let's say, will add to, um, let's call this, it's going to add to 9k plus 9 times n minus 1. So in the case of column 1, column 1 will add to 9k, column 2 to 9k plus 9. This is all in this world where we're just considering consecutive numbers. And therefore, if column 1 is divisible by 9, then so are the remaining columns. Okay, it's pretty difficult getting this down in a concise way. I'm going to show you the solutions right at the end. Okay, so I'm just going to go over this again. Right, all the rows work. They must work every time. They all add to 45. The columns only, if you pick the first 8 however you like for in column 1, which then decides column 2, column 3, and so on, there's only one number that is going to work out of the 9 digits as the bottom number in a column. So 1 over 9 of the first column are going to be satisfying the condition. And then it turns out that, okay, if you look at the next column along, everything's just going up by 1, essentially. And we can just say that it's going up by 1 because 9 going to 1 is equivalent to 9 going to 10. That's what I'm trying to get across with this statement here. So if column 1 is divisible by 9, so are the rest of them. That is the key thing that I'm saying here. So at this point, I only need to consider the diagonals. Okay, I'm going to get x1 plus x2 plus 1. I'm going down this diagonal here. plus x3 plus 2 all the way to x9, well, I'll be adding 8. And that is going to equal x1 plus x2 plus x9 plus 1 plus 2 up to 8. And remember, when I added 1 to 9, I had 45. So if I minus the 9, that's going to give me 36. This is equal to 36. So if column 1 is a multiple of 9, then so is this diagonal. Because I just get the... Remember, I'm still dealing in this world of the numbers being consecutive, but we can just assume that from now on. And that would mean this diagonal is because I've got multiple of 9 plus 36, which is also a multiple of 9. Should have maybe just pointed that out. And we've got the other diagonal, which is going to work in a very similar way. It's going to be x9, because I'm going from here to here. So it's going to be x9. Maybe I'll start with x1 plus 8. Plus x2 plus 7. So x9. And that is again going to be x1 plus x2 plus x9. I'm going to get the same sum. Also divisible by 9 if the first column is. And we're ready for our conclusion. So once more, every row will necessarily be divisible by 9. 1/9 of the first, not 1/9 of that first column will be divisible by 9, because there's one digit right at the end that you pick to make it such that. That's true. All the other columns then, it will follow that if the first column is divisible by 9, then they will be as well, because we're just adding 1 on each time, essentially, when we consider this consecutive sum idea, consecutive digit idea. And if it's not, then they're not either, but that's irrelevant because all of them have to be for the grid to be gorgeous. Then we just take a look along the diagonals, and if the first column is divisible by 9, then the two diagonals will be as well. Meaning, overall, 1/9 of the grids will be gorgeous. And therefore, 1/9 times 9 to the 9 equals 9 to the 8 grids. Okay, I've done my best to explain that. Have a look at the official solutions as well. They're maybe a little bit more concise. I've tried to make this video to make things a bit clearer by using examples, numbers, and so on. So I hope that makes sense. Well done for sticking around and watching this. Thanks.